This is Ham College, episode 47 for November 30th, 2018. Ham College is brought to you by ICOM. The holidays are just around the corner, and ICOM has plenty of cheer for everyone. Surprise your favorite ham this season with the gift that's on their hot list. And by hamstudy.org, a great way to study for your next license exam. Well, good evening. Welcome to another exciting episode of Ham College. I'm Professor Thomas.
And I'm Dean Martin.
And this is I guess it's the Christmas episode of Ham College, no? Or is it the Thanksgiving?
No, I guess this would be the Christmas one, because Thanksgiving's behind us and Christmas is the next thing.
But it's still
there
November.
Won't be another yeah, but there won't be another show before Christmas.
Well, that is true. Well, what did we talk about last month?
Oh, let's see. Solar effects and...
You found the note tonight.
Yeah, I found the note tonight. We talked about antennas, solar.
Loops.
Loops.
Log
periodic antennas.
Mm-hmm.
Yeah, I knew that's what we did.
So what are we going to talk about tonight?
We're going to answer some questions.
That's one way to put it.
We're going to talk about beverage antennas.
We will be doing that a little later in the show.
Yeah, and I don't know. Yeah,
we've got some questions related to sideband. Now we have covered single sideband before, so we're not going to dig too in depth in that, but we're going to get into it a little bit tonight and get through these questions here. We're going to study a little bit about about hopping up your modulation.
Sounds good.
Yep.
We need to do that.
And we're not talking about a power mic.
Oh, no D104s?
No, not your Turner Plus 2 either. All right, so anything else we need to mention before we get into the questions tonight?
Yeah, if you are watching the live feed and you're not over in the chat room, come join us over there.
That's a good point, yeah.
AmateurLogic.TV /chat will get you there. And if you're watching the live feed, you're missing half the fun, because it's a great group of people over there having a good time, and we interact with it some through the show as we can.
Mm-hmm.
Anyway, join us over there.
First question tonight.
Oh, you didn't waste any time.
Well, I didn't.
You got the buzzer ready?
Close enough.
Okay.
I'll ask you this one. What type of modulation varies the instantaneous power level of the RF signal? Is it A, frequency shift key?
B, phase modulation?
C, frequency modulation?
Or D, amplitude modulation? So I guess you expected me to answer this one.
Well, yeah.
What type of modulation varies the instantaneous power level of the RF? The power level.
Instantaneously.
That would not be frequency shift keying, because it wouldn't.
Okay, I'll go with that.
Phase modulation. No, it wouldn't be frequency modulation, because we're not altering the frequency. It's going to be amplitude modulation.
I could kind of see where you were headed there.
Yeah, right down to the bottom of the list.
Yep. Well, let's find out if you get a fist bump or a buzzer.
I'll get a fist bump?
Yep.
Cool.
Amplitude modulation.
Am I going to get a fist bump when my computer over here restarts on its own, because it just put updates on there?
You think it did?
Oh, yeah, it just did.
Oh, okay. Well,
I don't know if it's going to restart or not. I hope not.
Let's just talk real quick about modulation. Now, this is not all types of modulation right here, but just AM and sideband. If you look there at that drawing, the top one there, a rough drawing of amplitude modulation, you see the two little humps, and in the middle there, that line going vertically, that is the carrier. And then there's a lower sideband and an upper sideband on it. So an AM signal is essentially that carrier, and then the modulation creates those sidebands on either side of it. The second drawing down, that's upper sideband modulation. You can see there that the carrier is gone. It's been suppressed, but there's only the upper sideband there. And the bottom photo, lower sideband there. And we've only got the lower sideband of the signal there. And once again, the carrier is suppressed. So just wanted to throw that in there. We've discussed all of these before in greater depth, but just wanted to briefly mention that before we got into these other questions here tonight.
Yeah, that's cool. It's good visual reference.
Yeah, and we didn't cover FM or phase modulation or any of that because, well, those don't really relate to what we're talking about tonight. So I guess the next one you're going to have to ask me.
Okay, we can do that. Which circuit is used to combine signals from the carrier oscillator and speech amplifier, then send the result to the filter in some single sideband phone transmitters? That's a mouthful. A, discriminator.
B, detector.
C, IF amplifier.
And D, balance modulator. Well,
I'm glad you drew this one.
Yeah. I'm going to have to read over that again. Which circuit is used to combine signals from the carrier oscillator and speech amplifier, then send the result to the figure in some single sideband phone transmitters? Well, let's see. A, discriminator. No. Discriminator, I know that's a component in a receiver, so that's not going to be used in a transmitter. A detector, that's also used in a receiver, not in a transmitter. An IF amplifier, well, I guess you could have one of those, and I know you got it in a receiver, possibly have one in a transmitter, but that's not what combines the carrier and the modulation together. It's the balanced modulator, D. So that's my answer. What do you think, Dean?
Oscillator, carrier oscillator. I think so. That should be it. I don't know the answer for sure, but that would be my guess.
Well, just about everybody is saying D, or not A, or not B, or not C. So I'm going to say it's probably D. There you go. Balanced modulator.
You nailed it. Interesting.
Yeah. As a matter of fact, well, let's do one more question.
I remember some of these when I took my test. I remember some of these about the stages, the different stages in transmitters and receivers, and some of those they weren't very intuitive.
Yeah.
Like ruling them out, it's kind of tough. Oh, it's basically what we just.
That's basically what we just. Yeah.
Yeah,
Yeah.
I couldn't say it any better myself.
So on the left-hand side, we've got a modulation signal, and we've got the carrier, and each of those feeds a balanced modulator. They're combined there. Then they go out to a filter, and then on out the transmitter. That's a very simplified drawing there of the front end of a sideband transmitter.
Well, that's how I like it, simple.
Which of the following is used to process signals from the balanced modulator, then send them to the mixer in some single sideband phone transmitters? Is it A, a carrier oscillator?
B, filter.
C, IF amplifier?
D, RF amplifier. Which following is used to process signals from the balanced modulator, then send them to the mixer? I'm going to go with B, filter.
B, filter. That's what virtually everybody's saying over in the chat room. Although I do see an A in there. I'm going to go with you. I'm going to say it's a B. Is that your machine about to reboot?
No, that's my watch.
Oh, is your blood pressure off or something? Or?
Probably.
Yeah. All right, well, let's see. B.
Filter. Which of the following this is an easy one. Which of the following phone emissions uses the narrowest bandwidth? A, single sideband.
B, double sideband.
C, phase modulation.
D, frequency modulation. Which of the following phone emissions uses the narrowest bandwidth? Well, I think everybody ought to get this one, especially after we looked at those drawings a little earlier of modulation. It's not frequency modulation. It's not phase modulation. You wouldn't think it's double sideband because that would just sound twice as broad as single sideband. It's single sideband, you know. It's like we took that AM signal, we cut the carrier out, we knocked off one of the sidebands, and it's much narrower. So I'm going to say single sideband A, and everybody's got that over in the chat room. I think that was a pretty easy one.
Yeah.
So
It should have been mine.
what is one advantage of carrier suppression in a single sideband phone transmission versus full carrier amplitude modulation? Is it A, audio fidelity is improved?
B, greater modulation percentage is obtainable with lower distortion.
C, available transmitter power can be used more effectively?
Or D, simpler receiving equipment can be used. What is the advantage of
What is one advantage?
What is one advantage then of carrier suppression in a single sideband phone transmission? A, audio quality. I don't think audio quality is not going to be improved. Greater modulation percentage is obtainable. No, available transmitter power can be used more effectively. I think that's what it's going to be. Or D, simpler receiving equipment can be used. I'm going with C, Charlie. Available transmitter power can be used more effectively.
Yeah, that's
Because it's not just drawing all that power at one time. It's only,
just concentrating it all in that one narrow spot.
yeah, right.
So that's what everybody's saying over in the chat room there. It is C. So you can kind of see.
I see.
Mm-hmm.
You can kind of see.
You can kind of see. You know, back before I knew what single sideband was, I just knew that people with the single sideband CB radios always claimed they could talk farther than the ones with the AM radios.
Mm-hmm.
And it's not.
It was true.
Yeah. It's not necessarily really that there's any more power there. It's just it's all being concentrated.
It's used better.
Yeah. More effectively.
Okay, here's one for you. What is the purpose of a speech processor as used in a modern transceiver? A, increase the intelligibility of transmitted phone signals during poor conditions.
B, increase transmitter base response for more natural sounding SSB signals.
C, prevent distortion of voice signals.
Or D, decrease high frequency voice output to prevent out of band operation. What is the purpose of a speech processor as used in a modern transceiver? Let's see. Well, I'll start at the bottom here. D, decrease high frequency voice output to prevent out of band operation. No, not really. C, prevent distortion of voice signals. If you overuse it, you could actually increase the distortion of voice signals. So it's not that. B, increase transmitter base response for more natural sounding single sideband signals. Now, A, increase the intelligibility of transmitted phone signals during poor conditions. That's the purpose of a speech processor.
Yeah, I could see why people could almost guess B though. Speech processor. If you weren't aware what a speech processor is.
Well, yeah, I guess if you weren't aware of what it was, if you ever turned it on your radio or well, You wouldn't probably hear the difference, but whoever you're talking to would. But let's go ahead.
I don't talk to myself on the radio. I just usually do that in person.
Yeah. Well, it's easier.
Yeah. I answer myself a lot quicker.
It's more efficient.
Yeah. It's hard to hear myself answer myself.
And they were all getting that right over in the chat room there. It is
Cool.
Increase the intelligibility of transmitted phone signals during poor conditions. You know, if you overuse a speech processor, it can really get on folks' nerves. Oh, yeah. Which of the following describes how a speech processor affects a transmitted single sideband phone signal? A, it increases peak power.
B, it increases average power.
C, it reduces harmonic distortion.
D, it reduces intermodulation distortion. Which phone describes how a speech processor affects transmitted signal sideband? Increases peak power. I don't think it's going to increase the peak power. B, increases average power. That sounds plausible. Reduces harmonic distortion. I don't think that's going to be it. And reduces intermodulation distortion. I don't think so. I'm pretty sure it's going to be B. It increases average power.
Yeah, that sounds.
Because it's almost like compression, right?
Well, yeah, it's our like clipping as well used to increase the.
So you're going to even out the audio. So I'm thinking the average is going to increase the average power.
Yeah, because it's going to keep your modulation up higher. Is essentially what it's doing, and you know that's where all the power is in sideband is with the modulation. So B, it increases average power. Everybody got that right over in the chat room as well.
I need to just start looking at the chat room first.
Yeah, and Don just asked, because I mentioned that question on Ham Nation this past week, that would be covering it tonight, and Don recognized it. In fact, yes, we are covering it tonight. Good catch there, Don.
Cool. What control is typically adjusted for proper ALC setting on an amateur single sideband transceiver? A, the RF clipping level.
B, transmit audio or microphone gain.
C, antenna inductance or capacitance.
Or D, attenuation level. What control is typically adjusted for proper ALC settings on an amateur single sideband transceiver? ALC means automatic level control. You would think maybe it could be RF clipping level, but that's not the answer. And it's definitely not the attenuator level or the antenna inductance or capacitance. ALC is automatic level control. Essentially what it's doing is B there. Transmit audio or microphone gain.
Nailed it.
Nailed it. It's similar to, some old tape recorders, cassette recorders and all that you would buy would have an AGC or an ALC on them. And that's essentially what they were doing, is adjusting the audio gain.
Interesting.
So, don't go away. We'll be right back. For the love of the holidays, surprise your favorite ham this season with the gift that's on their hot list. The holidays are just around the corner, and ICOM has plenty of cheer for everyone. IC7610, the SDR every ham wants, and just in time for the holidays. This high-performance SDR has the ability to pick out the faintest signals, even in the presence of stronger adjacent signals. The ICOM IC7610 is a direct sampling software-defined radio that will change the world's definition of a SDR. RF direct sampling system, 110 RMDR, independent dual receivers, and dual digicell. IC7300, changing the way entry-level HF is designed. This high-performance, innovative HF transceiver with a compact design will far exceed your expectations. RF direct sampling, 15 discrete bandpass filters, large 4.3-inch color touchscreen, real-time spectrum scope, and SD memory card slot. ICR30. Raise the bar on DC to daylight receivers. Powerful yet easy to use, the ICR30 is packed full of features you've come to expect from ICOM. Built-in GPS and Bluetooth, dual bandwidth recording, high-speed scan, and there's an Android and iOS app available. The perfect stocking stuffer, the ID51A Plus 2 provides new modes for extended D-Star coverage. Enjoy integrated GPS, independent AM/FM receiver, and free Android apps. Terminal and access point mode, send and receive text messages and pictures. DV fast data mode, and easy FM repeater setting. Visit ICOMAmerica/amateur for more information on all the great ICOM radios. And thanks, ICOM, for being a sponsor of Ham College. Couldn't do it without you.
Yep, absolutely. Man, I like that receiver, the little ICR30
that is
receiver.
Pretty neat, yeah.
I'd really like to have my hands on one of those things. For the traveling, that'd be pretty fun to have a really broadband receiver like that. You know, covers that much.
Almost DC to daylight.
Yeah, we probably find some pretty cool stuff to listen to.
Yeah. Well, we've got something to give away here. We do it every month on Ham College. We've got an ICOM ball cap. And what else have we got there?
We've got an ICOM Ham Crew t-shirt.
And we do a contest every month. All you need to do is send an email to hamcollege@AmateurLogic.TV. And you don't really have to put anything in particular in there. Just give us a name, your call sign if you got one. Now you can drop a note in there and say hi or whatever you might like.
If you win it and you wear it, you'll look something kind of like that,
but with a head. Yeah.
But with a head.
Yeah. And you'll look just as good coming as you will.
You will as you will coming to the Ham Fest as you will headed home.
Yep. Okay.
Good, nice shirts, man.
Well, we did.
I got mine back.
A drawing right before the show tonight, and our winner for this month is Stuart Kirker, W8SDK.
Oh, software developers kit.
Yep. Congratulations, Stuart.
Awesome. Congrats, Stuart. ICOM will be in touch with you pretty quick about that.
Mm-hmm.
And so if you entered in the contest or you didn't enter in the contest and you want to be in the next one, send your information to Ham College at AmateurLogic.TV. What information they need, George?
All they got to have is a name and an email.
An email address.
Yep.
Don't get much easier than that.
That's about it.
Pretty much everybody's got a name.
So congratulations, Stuart. Ham College at AmateurLogic.TV.
Yep. So, if again, we've said it before, but if you entered and you didn't win, you need to enter again because it starts off with a clean slate after we draw. So,
yep.
Anyway.
Yeah, we empty the inbox and start over every time.
Yep. So, enter again.
What is likely to happen if a transceiver's ALC system is not set properly when transmitting AFSK signals with the radio using single sideband mode? A. ALC will invert the modulation of the AFSK mode.
B. Improper action of ALC distorts the signal and can cause spurious emissions.
C. When using digital modes, too much ALC activity can cause a transmitter to overheat.
Or D. All of these choices are correct. Okay, I'm going to have to read this one over again and read each one of the questions pretty carefully, I think, because it's kind of wordy.
Yeah.
So it's easy to get tripped up on the ones that are kind of long like that. What is likely to happen if a transceiver's ALC system is not set properly when transmitting AFK, which is frequency shift keying signals, with the radio using single sideband mode? A. The ALC will invert the modulation? I don't think so. I'm going to scratch A off of the list. Improper action of ALC distorts the signal and can cause spurious emissions. It's not set properly. That sounds plausible, but let's look at the other two. When using digital modes, too much ALC activity can cause a transmitter to overheat. No. Or D, all these. It's not D. They're not all correct. So the only one that can be is B. Improper action of ALC distorts the signal and can cause spurious emissions, because the other three just don't really make any sense at all.
Yeah, and that's what everybody's saying over in the chat room is B. I'll agree with you. Improper action of ALC distorts the signal.
In my mind, they didn't make any sense at all, so must have got it.
Well, I think we got one more question here on ALC. Let's see. You can ask me this one.
Okay. What is the reason to use automatic level control, or ALC, with an RF power amplifier? A, to balance the transmitter audio frequency response.
B, to reduce harmonic radiation.
C, to reduce distortion due to excessive drive.
Or D, to increase overall efficiency. What is the reason to use ALC with an RF power amplifier? To balance the transmitter audio frequency response. That's not it. That's not necessarily something that you'd want a special control to do. To reduce harmonic radiation. No, it's not going to do that. It could, it could actually overuse, could create some harmonic distortions. So it's not going to reduce distortion due to excessive drive. Well, it could. And to increase overall efficiency. No, if you're using it with an RF amplifier, what you're trying to do is keep from overdriving that amplifier. You haven't used a linear amplifier on a ham rig, have you?
No.
There is a special line that goes on the back of your radio. It's the ALC output of the rig, and it goes down to an ALC input on the amplifier. And essentially, that's what it's doing. It's preventing you from overdriving the amplifier. So I'm going to say it's C.
Yeah, it got to be then.
Yeah. Everybody over in the chat room says it's C, so a good chance I'm right on that. There you go.
I see.
To reduce distortion due to excessive drive. Because most of the time our rigs have enough power to overdrive an amplifier.
Oh, yeah.
And things can get real nasty if you do that.
Interesting.
Yep.
I really ought to get an amplifier one of these days. I'd like to get some experience with it. And
you should
bust the pile-ups a little easier.
It makes it a lot easier when there's a lot of people there and you're trying to talk. Or particularly if you want to talk on 75 or 80 meters in the summertime, you just about need it to overcome the static. In a lot of cases, it really helps. All right, and I'm going to ask you this one. What condition can lead to permanent damage to a solid-state RF power amplifier? A, insufficient drive power.
B, low input SWR.
C, shorting the input signal to ground.
Or D, excessive drive power. Okay. Insufficient drive power. I just think you're not going to get enough out of it. Low input SWR, that doesn't make it, that's not a problem. Shorting the input signal to ground. The input signal? No. Excessive drive power? That's the answer right there. D, excessive drive power. We already touched base on that tonight anyway, so.
Yep.
But I do know that could damage it. I've read enough about that and talked to enough people.
Everybody in the chat room saying D. I'm going to agree with you. Excessive drive power. I think, well, we didn't just say that, but
Well, we kind of talked
kinda
about it a little
about
bit,
it,
talked
yeah.
around it.
So, smart group in there, smart class tonight.
They're sharp. You can't trip
Yeah.
them up.
They hadn't, no one's hardly missed anything.
Wait till we get to the next round of questions out here about the next topic.
Yep. And as a matter of fact, we're going to talk a little bit about the next topic before we actually get to the questions.
We're going
on
to
it.
talk about it before we talk about it?
Sort of like that, yeah.
Okay.
We're going to talk about a Beverage antenna. It's named for Harold H. Beverage. He was experimenting with receiving antennas similar to the Beverage antenna in 1919 at the Outer Cliffs radio station. He discovered in 1920 that an otherwise nearly bidirectional long wire antenna became unidirectional by placing it close to the lossy earth and by terminating one end of the wire with a resistor. By 1921, Beverage long-wave receiving antennas up to 9 miles long had been installed at RCA's Riverhead, New York, Belfast, Maine, Belmar, New Jersey, and Chatham, Massachusetts receive stations for transatlantic radio telegraphy traffic. The antenna was patented in 1921 and named for its inventor, Beverage. Perhaps the largest Beverage antenna, an array of 4-phase Beverages, 3 miles long and 2 miles wide, was built by AT&T in Halton, Maine, for the first transatlantic telephone system, and it opened in 1927. Now, the Beverage antenna is used a lot by amateur radio, shortwave listeners, long-wave radio DXers, and military applications. A Beverage antenna consists of a horizontal wire from 1/2 to several wavelengths long. That's hundreds of feet at HF to several kilometers for a long wave, suspended above the ground with the feed line to the receiver attached to one end and the other end terminated with a resistor to ground. In this photo here you can see rather than going directly to the ground, they've got a counterpoise wire serving the same feature there. The antenna has a unidirectional radiation pattern with the main lobe of the pattern at the shallow angle into the sky off the resistor terminated end, making it ideal for reception of long-distance skywave or skip transmissions from stations over the horizon which reflect off the ionosphere. However, the antenna must be built so the wire points at the location of the transmitter. The advantage of a Beverage are excellent directivity and a wider bandwidth than resonant antennas. The disadvantage, number one, is physical size, requiring a considerable land area, and the inability to rotate to change the direction of reception. Installations often use multiple antennas to provide wide azimuth coverage.
That's pretty interesting. You know, as long as I've been a ham, I've never really looked into that, how it worked. And I've seen it. Jimmy made one, and I saw it at his house, but it didn't look like that. It almost looked like a curtain.
Yep.
Anyway.
Well, to be honest, this is the first time I've ever looked into it.
Really?
Yeah.
Well, good.
And
so maybe we'll both get buzzed tonight.
I've heard of lots of people building Beverages.
Yeah, everything just makes me thirsty.
Makes me kind of thirsty too, but it also makes me know that I don't have enough room here on my property to install one.
Well, if you make one like Jimmy made, it wasn't that big. I'm not sure what it was cut for.
Yeah, it depends on what band you want to operate on. But yeah,
I'll have to check with him and see.
Yeah.
But it looked like basically looked like a frame with a bunch of vertical wires in it.
That was a curtain antenna, I think.
Well, I'm pretty sure he said it was a Beverage. I'll have to look that up. But this, like I said, I haven't done anything with them, so
Yeah.
there's a good chance that buzzer's going to be going off here shortly.
Okay, well, right now, I think we'll regroup, take a break, and come back and have a beverage.
Okay.
Good evening, folks, and a hearty welcome to our drive-in theater. We have a wonderful evening's entertainment lined up for you, one that will provide several hours of pleasurable relaxation and diversion for you and your family. Did you fail to dress up for tonight's show? No tie, an old shirt and slacks, a house dress? Well, don't give it a thought. We're glad you came as you are. We just want you to enjoy yourselves. Don't forget to visit our refreshment center during the intermission or any time. You love the tasty array of snacks we have to offer. So will the youngsters. Everything is quality and so good. We hope you'll make this a weekly visit. Bring the family. Bring your friends. There are always wonderful new pictures to see, delightful snacks to nibble, a gay, pleasant evening for all. Oh, a word of caution. Don't drive over 10 miles an hour in the theater area for your safety's sake. And Mom or Pop, go with the kids when they leave the car. We hope you have a wonderful time. Come back soon.
Christmas in Australia can be pretty tough, but at Dick Smith Electronics, there's something for everyone with a complete range of home electricals. Toys for fun and toys for learning. Everything in communications. Radios and cassettes. There's tools and electronics. It's like 8 specialty stores in one. Take it from the expert. Shop at Dick Smith Electronics.
Are you new to the ham world or an existing amateur operator who wants to take your license to the next level? Study for your radio license exam at hamstudy.org. Hamstudy.org is a free online learning tool powered by ICOM. It was created by Richard Bateman, KD7BBC, Michael Stufflebeam, KV9G, and Rich Porter, KK6GKE, and it uses a modern web design to enhance the experience of studying for your technician, general, and amateur extra exams. Since 2013, hamstudy.org has helped new and existing hams to familiarize themselves with the question pools, use stats-based flashcards to focus on material they need to learn, and take practice exams to gauge progress. Visit hamstudy.org on your desktop computer or mobile device. Register for a free account at hamstudy.org to access personalized study history and other site features. Prepare for an exam in an intuitive and comprehensive manner. Check out hamstudy.org, powered by ICOM, for free learning tools. Good luck on your next exam.
Are you keeping up with the Commodore? 'Cause the Commodore is keeping up with you. In a world of fun and fantasy, and ever-changing views, and computer terminology, Commodore is news. Are you keeping up with the Commodore? 'Cause the Commodore is keeping up with you.
Everywhere you go, there's a Commodore store.
Commodore is keeping up with you.
This diner is pulling a switch on the regulars by serving new instant Maxwell House. What's it taste like? Fresh perk coffee, that's what it tastes like. New Instant Max. Now a better blend of coffee beans, freshly perked for more fresh perk taste. We call it the Perky Instant.
Nothing upsets a pickle lover more than a dull, soggy pickle. Pickle lovers always insist on the proud pickle. Heinz. No compromise, no shortcuts, no soggy pickle. Heinz stops at nothing to give you a pickle that tastes the way no other pickle does. Crisp, full-bodied, savory. That's what makes Heinz the proud pickle. If you were the best tasting pickle, wouldn't you be proud?
The percolator coffee thing's one that got me. Like, most people now don't even know what a percolator is.
And that was some first-class acting on that commercial,
It was.
too, I got to say. But yeah, I remember that. I guess that was the only way to make coffee back in the day.
They were instant.
Yeah, before they had instant.
Yeah. Well, that's pretty wild.
Yep.
I could use a cup of that coffee right now, except I don't want to make all that noise.
Yeah, that would be kind of hard to follow. Well, as promised, we've got some beverage to talk about. Which of the following describes a beverage antenna? Is it A, a vertical antenna?
B, a broadband and mobile antenna.
C, a helical antenna for space reception?
Or D, a very long and low directional receiving antenna. Wow. Seeing how you just told me about that, I'm going to have to choose D.
That would be a good choice. That's what everybody's choosing over in the chat room there. So, yeah, I'll agree with you too. D. A very long and low directional receiving antenna.
Yep. Low to the ground.
Yep. All right.
It's an interesting concept. I'm going to read up some more on that. I've heard about them, but I've just never really bothered to look into them much.
There's actually a lot more to it than, because I had about twice as much stuff to read about that and just decided it was too much. But it's real interesting. Go to Wikipedia and look up beverage antenna and do some reading on it. It's quite interesting.
Okay, here's one for you. Which of the following is an application for a beverage antenna? A, directional transmitting for low HF bands.
B, directional receiving for low HF bands.
C, portable direction finding at higher HF frequencies.
Or D, portable direction finding at lower HF frequencies. Which of the following is an application for a beverage antenna?
What say you?
Well, I know it's not used for transmitting, so it's not A. It's not a portable direction finding antenna at lower HF frequencies. As a matter of fact, it's not portable at all. So knock out C or D. That only leaves B. A directional receiving antenna for low HF bands, or actually the correct wording is directional receiving for low HF bands. That's my answer.
Everybody's sticking to it?
Everybody's saying B over there in the chat.
You don't want to phone a friend or do a lifeline?
No, I don't think that'll be necessary.
Required? Okay.
Yeah.
Well, you nailed it.
Directional receiving for low HF bands. Why is a beverage antenna not used for transmitting? We didn't talk about this. A, its impedance is too low for effective matching.
B, it has high losses compared to other types of antennas.
C, it has poor directivity.
Or D, all of these choices are correct. Okay, so one of them says it has poor directivity. That's not right, because we just said it was highly directional.
Okay.
So that means D's not right either. So let's get rid of C and D.
Okay.
Because if C's wrong, D's definitely got to be wrong. Or not valid. Has high losses, or its impedance is too low for effective matching. And if you can tune up a chain link fence, it's got to be B. It has high losses compared to other types of antennas.
Okay, we're a little mixed over in the chat room now.
I may be about to get buzzed, but that's one I think it is. It has high losses.
Well, I'm going to agree with you.
And the only reason I say that is because you can tune up pretty much anything. I just think it's...
There you go. It's B. This is the only question that's really kind of stumped the folks over in the chat room a little.
Yeah, I could see that. Which of the following most limits the effectiveness of an HF mobile transceiver operating in the 75 meter band? We've been jump topics. A, picket fencing signal variation.
B, the wire gauge of the DC power line to the transceiver.
C, the antenna system.
D, FCC rules limiting mobile output power on the 75-meter band. Which of the following most limits the effectiveness of an HF mobile transceiver operating in the 75-meter band? Well, there are no special power limits in the FCC rules for mobile operation. As a matter of fact, our friend Dan in 9LVS, I believe his mobile rig will do 1,300 watts.
Yeah, the only limit's the 1,500 watt ceiling we have.
Yep.
Pretty much, period.
Picket fencing signal variations, A. Now, that's not it. You know, that's a problem we have up on 2 meters and such. But and it is a mobile phenomenon. So you might be, you know, kind of steered that direction, but that's not right down on these frequencies. B, the wire gauge of the DC power line to the transceiver. Well, I guess if you had tiny, skinny wire, maybe that might be a problem, but generally we don't, you know. We can make up for that easy enough. It's the antenna system. You know, it's hard to get a big antenna on a mobile system. If you think about the 75-meter band, a half-wave antenna is going to be, what, close to 130 feet? So a quarter wave is going to be half of that. You just don't see many people going down the road with a 65-foot antenna on their car.
That would be well to see, though.
That would. So I'm going to say it's the antenna system, C. We can, and everybody's saying that over in the chat room.
Yeah, I think you're right, too.
You know, we've got antennas that work on the 75-meter band for mobiles, but their effectiveness is limited because they're smaller and they're compromised, but they still work. So it's C, the antenna system.
Yeah, you nailed that one.
Well, let's see if you'll nail this one.
Uh-oh.
What is one disadvantage of using a shortened mobile antenna as opposed to a full-size antenna? A, short antennas are more likely to cause distortion of transmitted signals.
B, short antennas can only receive circularly polarized signals.
C, operating bandwidth may be very limited.
Or D, harmonic radiation may increase. Disadvantages. One disadvantage of using a shortened mobile antenna. Short antennas are more likely to cause distortion. A's not true. B, short antennas can only receive circular. No, that's not true either. Operating bandwidth may be very limited. Yeah, I'm thinking that's going to be it. Harmonic radiation. It's got to be C. Operating bandwidth may be very limited because we're using typically compromises to shorten those. I think it's going to be C. Operating bandwidth may be very limited.
And there again, smart chat room tonight, everybody's saying C. You know, when we have a short antenna like that, we've got to do a good bit of matching to it, or tuning to make it resonant at these lower frequencies we're trying to operate, and that really narrows up the bandwidth right there. You know, you're getting down to where you just change frequency a little bit, and you've got to retune the antenna to make it work.
What is the purpose of a capacitance hat on a mobile antenna? I'm glad you got this one too. A, to increase the power handling capacity of a whip antenna.
B, to allow automatic band changing.
C, to electrically lengthen the physically short antenna.
And D, to allow remote tuning. What is the purpose of a capacitance hat on a mobile antenna? Well, I just happen to know the answer to this.
I figured you did.
Yep. And as a matter of fact, I have an AM broadcast station that has capacitance hats on its 3 towers. It's directional.
That was convenient.
It's not mobile.
It's not?
No, it's not mobile. But
That would be well to see too.
the towers are a little too short to be used. Well, let's just look at the answer here. To increase the power handling capacity. No, it's not that. To allow automatic band changing. It's not that. To allow remote tuning. It's not that. It's C, to electrically lengthen a physically short antenna. There again, everybody's got that right over in the chat
That
room.
would have been my guess
Yeah.
too.
So, back to my AM antenna story there. We've got the tower, and I should have drawn it out ahead of time. We got a tower here. It's not a full quarter wavelength tall. This station is on 1180 kilohertz.
Mm-hmm.
All right. The antenna is less than a quarter wavelength tall. So to make it appear taller, on an AM station, our guy wires, well, I can't really draw this. Our guy wires coming off the tower. I'm running out of ink. Well, I wasn't meant to show you this tonight.
Bar mine.
We got insulators, in the guy wires so that the guy wires don't touch the actual tower. They're sitting out there segmented. Generally, those are broke up into lengths that are less than 1/10 of a wavelength.
But the tower itself is the antenna.
The tower itself is the antenna. The guy wires there are insulated from it, just hanging out there just to hold the tower up, but they're not part of the antenna system. However, a capacitance hat, and I need to add that, the top set of guy wires actually touch the tower. On all these others down here, they don't. There's insulators right there at the tower. But a capacitance hat, that top set of guy wires is actually connected physically to the tower, and then the insulators are down here a little further, a specific length there to make that antenna appear taller than it is.
Oh, that's interesting.
And it's kind of weird to look out there and notice, all the insulators there in the guy wires where they normally would be, except this top set here, connected right to the tower. Now, on this particular tower, those insulators are more like this right here. It's got a connection
Oh, they're longer.
to either side, and then there's a fiberglass rod here.
So you got more space between the
Yep.
wire.
Because this is on a 50 kilowatt transmitter.
It's an arc.
And yeah, so you need a little more insulation there, so they're using the fiberglass rod. I went out there one day, the transmitter wouldn't stay on the air. I drove out to see what was wrong, and it was a high SWR every time you punch the button on. I looked out at the tower. One of those had actually burned in half.
Oh, wow.
It had gotten a lightning strike that made it arc a little bit, and then all it took is that 50 kilowatts just burning on up, and that line right there was just hanging down low, bumping into the tower.
Oh,
So,
that's interesting.
yeah. So that's basically what a capacitance hat is. And they work lovely for amateur radio too, for a 160 meter band. If your tower's a little short for 160 meters, you can whip out that capacitance hat there on it and make your transmitter think, hey, this antenna's a quarter wave. And there's other ways.
Does that affect the bandwidth too?
It does. You can do that because what we're trying to do is make that that tower look like 50 ohms to the transmitter.
Mm-hmm.
All right. We can do that with a matching network down here. Even if the tower is, less than a quarter wavelength, we can make that matching network make it thinks it's looking at 50 ohms. But if we do with the capacitance hat, we're actually, we don't have to do that in the matching network. The tower itself, it appears like it's a quarter wave. So, yeah, a little better bandwidth. Exactly like you said there.
Cool. Interesting.
Marty says he's seen those on AM transmitter towers and didn't know what they were. Well, there you go, Marty. There's also different styles of those. I've seen some, and I think there's one in New Orleans, maybe. But I've seen photos of it. I've never worked anywhere that had one, where the top of the tower, it's a, yeah, you can't really see that, can you? It's like a self-supporting tower, and there's like these arms that are like an umbrella on
Like
top
somebody,
of it.
yeah, like somebody put an umbrella up there and stripped the cloth off of it. I've
Yep.
seen those.
That's doing the same thing.
Okay, I've seen those at the
At rest areas?
yeah, at the like at the way station when you're going from Mississippi into Alabama, right there where that wide place is.
What that's being used for right there, though, is for as part of the lightning.
Well, it looks just like
Yeah, part of a
it
lightning
looks just like
arrestor.
you drew it up there.
Yeah, but they have made self-supporting towers. They couldn't, they don't use guy wires on self-supporting towers, so they can do their top load intercapacitance out like that.
Cool.
So there you go. What do you say we take a quick break, come back and chat with the...
Was that the end of the
who did we chat
questions?
with? Well, actually, no. I think we got one more.
Oh, saving the best one for last.
Yeah, let's just go ahead and knock it out then.
Oh.
What is the purpose of a corona ball on an HF mobile antenna? A, to narrow the operating bandwidth of the antenna.
B, to increase the Q of the antenna.
C, to reduce the chance of damage if the antenna should strike an object.
Or D, to reduce the high voltage discharge from the tip of the antenna. Okay, I'm gonna make a guess just from things that I've read and stuff. Talking to this actually kind of makes me think of when we went to up there to the station up in Ohio. Him talking about arcing, but I'm pretty sure the answer is going to be D, to reduce the high voltage discharge from the tip of the antenna. And it makes me think that because it says corona ball.
Yep.
So I can't reason out why the others are, but I think that's the answer.
Well, I'm going to agree with you, and everybody over in the chat room that's saying it's D. Except there's one fella in there that had the same thought I did. Kevin K4IVE said it's C and D.
Yeah, I could see where C would be similar to the thing you just drew there.
I'd a lot rather be poked in the eyeball with the corona ball than the end of a whip without one on it.
Mm-hmm.
But that's not the answer. So there you go, and I think that is all the questions for tonight.
I would like to see that sometime. Not
What, me
not
getting poked in the eyeball? No.
Hey, come here.
All right, we'll be back in just a second. Around the 15th of each month, it's Amateur Radio's original and longest-running video podcast, AmateurLogic.TV, with hosts George Thomas, Tommy Martin, and Emil Diodine. Roughly, here's what I have. The bottom trace here is ground.
While the elements will jiggle some, they're actually not too bad. It's light.
After putting it together, I decided to test everything, so I ran in 12 volts, and I'm measuring the output here.
No, it's not too windy right now, Jim. It was yesterday.
We're in the antenna switching matrix. Any one of our 6 broadcast transmitters could be connected to any of the 22 antennas.
I personally am so thrilled that George got the special award. Well deserved, my friend. That's really cool.
What about the Super Bowl, Emil? Did you go to the Super Bowl, or were you at home operating that night?
Tuning my amplifier, and I lost power in the shack and went outside. The house lost power. The whole neighborhood went out for about 30 minutes. I don't know what happened.
That explains a lot. Now we can take this and put it over inside our box. It's flush to the bottom. If we were to rotate, we can see that thing goes all the way through, so we'll have a hole in the bottom.
Here's what it looks like after I've got them all soldered together and heat shrinked up. Okay, let's give it a try and see how it worked out. So there you have it, the hula loop. No, you can't null out the dogs barking.
I have 2 thin film solar cells to run this. Looks like a little mini weather satellite, actually. And I'm using guitar string for the antennas.
I particularly like that last one there, $29.99. You can get a 50-foot garden hose extension cord combo.
Do not get cord wet. Now, most of these J-poles are built with metal elements or tubing. The reason I chose wire for this one is the length of this particular one. So I wanted to hang it from the tree so I can hoist it up there.
Yeah.
Go fishing.
We couldn't find the reel.
Yeah.
Is that what that is?
All right, Tommy, sing the theme song here. Well, thanks for being here tonight, everyone. Always a lot of fun. And, we didn't stump y'all too good with the questions tonight.
But we got you. We're going to try to do better next time.
Next year.
No. December, end of December.
There will be one at the end, excuse me, at the end of December. So it's like, sometime before the first of the year. All right.
Yeah.
7-3, y'all. Thanks for being here
7-3,
tonight.
everybody.
I'm about to lose my voice. I think I have lost it.
That would be like the 28th.
The 28th, you think? Maybe. Sometime around then. All right. Good night.
7-3, everybody. Good night. A, increase the intelligibility.
Huh?
Yeah.
If you overuse a speech processor, it can really get on folks' nerves. Oh, yeah. I was thinking about doing a little demo on it here tonight, but I was going to have to record it, and I didn't.
You didn't want to get on anybody's nerves?
No.